so far in our unit, we have solved rational equations. Those were our fractions. If you don't remember how to do those, you got to come see me after school. I have lots of them to help you practice, to refresh your memory on those. Then we did our word problems involving our rationals. And then we did our absolute value equations and inequalities. We did practicing with radicals, which we did a little bit more of it. We did our radical equations. We did our powers of I. Now we're going into quadratic equations. We have lots of different ways of solving our quadratic equations. But before we get into that, we're going to learn our last type of factoring that you guys haven't learned yet, and that's our factoring by grouping. So this is going to give us a total of 4 different ways in order to factor things. So to factor by grouping, step 1 is you want to group your first 2 terms together and your last 2 terms. So you group your first 2 terms, group your last 2 terms. So taking a look at example 1, what I mean by that is my 3x cubed and my x squared, I'm going to group those 2 together. And then my 15x plus my 5, I group those 2 together. So that's our first step. Second step, you're then going to GCF factor your 2 groups. So looking at our first example, looking at my first grouping, I have 3x cubed plus x squared. What would be our GCF here? X squared. So then I would be left with a 3x plus 1. And yes, you have to have that plus 1. It's kind of like a placeholder. What would be our GCF in our second group? 5. So again, I would take out a 5. I would be left with 3x plus 1. We know we've done it correctly because those should be exactly the same inside the parentheses. Ours match. They're both 3x plus 1. So far, so good. So then third step, Third step, you have to do GCF factor again with your binomial. So this is going back to our very second day of notes. We talked about a GCF factor with a binomial. For ours, it's this 3x plus 1. That's our GCF factor this time. So I'm going to take out my 3x plus 1. And then what's left? We're left with this x squared here plus 5. So they get grouped together in the other parentheses. So really, there should kind of be like a fourth step here. Factor again if possible. But looking at my 2 sets of parentheses there, 3x plus 1, I can't factor anything out of there. There's no GCF. There's no square term, so there's not a dots or trinomial. This looks very much so like dots, but it's not. Why? Can somebody tell me why it's not dots? It's not subtraction. We got plus sign here. That's our first sign. We don't have a dots problem there. So this one is actually done. Because this is an x squared plus 5, it needs to be a minus, and 5 also isn't a perfect square. All right, so let's take a look at example number 2. So again, I'm going to group my first 2 terms, group my second 2 terms. And step 1 is complete. So when I look at my first grouping, what is our GCF here? X squared. And then I would be left with a 3x plus 2. Now within my second grouping, since the first term is a negative, that means I need to factor out a negative number. So what's the number that goes into both of those? 9. And so we're going to take out a negative 9, which makes all of our signs change. So now what we have in our parentheses matches. If I didn't factor out that negative, my parentheses would not have matched. I wouldn't have done it correctly. So now I'm going to take out my GCF. which would be 3x plus 2. What goes in my next set of parentheses? X squared minus 9. Can I factor again? Yes, x squared minus 9. That one is a dots example. So 3x plus 2 stays as 3x plus 2. What does x squared minus 9 factor into? X minus 3, x plus 3. So that's our final answer there. So here we go. I'm going to group my first two terms, group my second two terms. What's our GCF in the first grouping? X squared. So then we're left with x minus 2. What's our GCF in the second grouping? 1. I'm going to take out a 1, which really means it stays as x minus 2. We just need that 1 for when we go to our next step of factoring by grouping. So my GCF this time is x minus 2. What goes in my other parentheses? Can we factor that again? No, because again, it looks like it's a dots problem, but it's not because it's got the plus, not a minus. Yes? Okay, example number 4. So we're going to first group our first two, group our last two. Now, do we have a GCF in our first grouping? No. So what we need to do for this one, and this is a very rare scenario, but sometimes it does happen, we have to rearrange the order so that I do have a GCF that I can factor out. So I'm going to change it to be x squared minus the bx, because then when I put those two terms together, what would be my GCF? An x. And then which term do you think I should put next? Now x squared, I already used my x squared. Or to use my bx, I would put ax first, and then my ab. Yes, Amir?
Could we also do x squared minus 8x? Or is it just bx?
All right, so when we group them, as I said, GCF here would be an x minus b. What would be our GCF in the second grouping? Not just a, negative a. And then we would have x minus b. That's why I put it in the order that I put it in, because I could see going forward that for this first term in the first parenthesis, I'd be left with an x. So I put the ax first so that my first term is also an x so that they would match. So then our final answer, x minus b times x minus a. So then my warning to you guys, I'm going to star this. Be very careful when you're factoring by grouping. Don't try to force it. If it's not working, you're going to have to try to find a different method for solving. So for example, right here is an example of somebody who tried to use factoring by grouping. It didn't work out. Where should have been their hint that it wasn't going to work out for them? Anybody? So they started with this. They started their factoring by grouping here. Where was their hint that it wasn't going to work? Paul? Here or here? This one?
Actually, no, the top one.
Mm-hmm.
The x plus, it was x plus 5 plus 3. They weren't matching. So
Those weren't matching. There's your hint right off the bat. This isn't going to work, so you would have to find another method. So the parentheses don't match. They need to match in order for you to do factor by grouping. So what I want you to do right now, I got 3 examples down here. I want you to do a little bit of practice of factoring by grouping. So try those examples down on the bottom. All right, so we got those 3 answers up there. How do we do? Okay? Questions on factor by grouping? out of the third one. You could. I didn't think of the GCF. So you could have, but then there's really nowhere else to go from there either. No, plus 2. Because I took a 3 out of here. I just put my 3 up in front because I'm used to putting the numbers all the way up in front. So yeah, either one of those would have been fine. All right, we ready to move on? Okay. Good? All right. Okay. All right, so for solving our quadratics, you have learned 4 methods so far. First method would be graphing. What shape does our quadratic look like? Has a special name. But that's not the special name. Parabola. So remember, your parabola can either go upwards, in which case where it crosses your x-axis, that is your answers. Do you guys remember what we call those? They got some special names. Roots. There's another one. Zeros. There's one more. Those are also your x-intercepts. Those 3 words, they use them interchangeably. What's the other direction our parabolas could take? They could be downwards. Again, though, where it touches or crosses your x-axis, that is your answer. Now, for those, some of these quadratics are going to lead to imaginary numbers. That means they're quadratics up here where there are no crossing. That's where our imaginary roots come from. They don't actually touch or cross your x-axis. Just a little side note. So another method we have learned for solving our quadratics is to factor. We now have 4 methods for factoring. You got your GCF, you got your dots, you got your trinomial, and now factor by grouping. So you have 4 different ways of being able to factor. A third way is by using your quadratic equation. I've started singing the song already to Madeline. She's getting ready to sing that for everybody. We got to get her to actually, say it. X equals negative b plus or minus square root b squared minus 4ac all over 2a. It's on the next page in notes. And then, anybody remember our 4th way? You did it a lot in geometry last year. I heard somebody say it. I heard somebody say it. Completing the square. We did do that in Algebra 1, but for a lot of people it didn't quite click. When you got to it in geometry, you got a lot more practice with your completing the square. So we're going to go over these different methods again to refresh your memories on how to solve our quadratics. So when we're solving by factoring, first thing we need to do is put it into standard form, which means you have your x squared term, your x term, then your number equals 0. Everything's on one side, equals 0 is on our other side, ax squared plus bx plus c. Once you have it into standard form, you then go ahead and start factoring. You set your factors equal to 0. And then you solve each of your factors. Now there is a little hint when you're dealing with your polynomials. Your highest exponent tells you the number of answers you will get. So with our quadratics, our highest exponent is a 2. You end up with 2 answers. We're going to have some that are cubes. You're going to have 3 answers for those ones. Fourth, you're going to have 4 answers for those ones. No, not that bad, I promise. So number 1, it's already set up for us in standard form. Everything's over on the left side. My equals 0 there, so I'm going to set up to factor. For 5x squared, that means my first terms are a 5x and a 1x. What will our signs be? Yep, both are going to be negative. And again, some of you are still getting thrown off by that middle term. Don't worry about the middle term just yet. You want to look at what multiplies to give us 8. I heard somebody say 4 and 2. But if I use 4 and 2, I don't think I'm going to get quite large enough. Let's try 8 and 1, because remember, to get your middle term, you've got to check multiplying those two inside terms. I like to call that my little smile. That gives me a negative 1x. If I were to multiply my two outside terms, my big smile, that's a negative 40x. That's where we get our negative 41x from. If I had used 4 and 2, I wouldn't have gotten anywhere close to 40. They're the 41 that we needed. So now we're going to set both of these equal to 0. Do we actually need to show that step? No, I'm just showing it to you to refresh your memory of what we do. Set those equal to 0. So with my x minus 8, I would add my 8 over. So x equals 8 is one of my answers. The other side, I would add my 1, divide by 5. So x equals 1/5 is our other answer. So 8 and 1/5. So if we were to graph it, we would cross the x-axis at 8 and at 1/5. Number 2, we don't have it in standard form yet. We have to get it into standard form. But first thing I want to do is I want to get rid of this fraction over here, our 40 over x. How do I get rid of that?
First divide by x.
You don't want to divide by x. You want to multiply times x. We're multiplying times the x because it's 40 divided by x. We got to undo that division. So that would give me 3x squared plus 19x when I multiply times x equals 40. Last thing we need to do to put it in standard form. Yes, got to subtract our 40. So we get 3x squared plus 19x minus 40 equals 0. So I'll give you guys a minute. Try factoring that on your own first. Does anybody think they got it? Well, what multiplies to give us 40? 1 and 40, 2 and 20, 8 and 5. So if I set it up this way, my little smile gives me a negative 5x, big smile, 24x. Combine those, there's my 19x. So we'll set them equal to 0. Over here on my left side, I would add my 5 over, divide by 3, so I get x equals 5/3. What's our other answer? X equals negative 8. So now examples like 3 and 4, a lot of people get confused when you see it in that method, but what they're doing is they started factoring by grouping for you already. They're kind of in the middle of the process. So they're at the point where here's your binomial GCF. So we're going to take our 2x plus 1, and what goes in our second set of parentheses? X plus 7 equals 0. So there we go. We're all factored out. We just have to set them both equal to 0. So my 2x plus 1, when I set that equal to 0, I get a negative 1/2. So I would subtract my 1, Divide by 2. What would our other answer be? Negative 7. How about for number 4? Same thing. They started factoring by grouping, so you got to pick it up in the middle. Here's our binomial GCF. So x minus 2. What goes in my other parentheses? 5x minus 4. So one of my answers is x equals 2. What's my other answer? X equals 4/5. So now examples 5 and 6, we want to use our new method of factoring because I've got 4 terms here. So I'm going to group my first 2. I'm going to group my last 2. What's our GCF in the first set of parentheses? X squared. And then I would have an x plus 2. GCF in the second set? Negative 9. Then I would have an x plus 2. Both of my parentheses are x plus 2, so they match. We did it correctly. This would be x plus 2, and then x squared minus 9 equals a 0. Now you can, but there is another way to solve that. Does anybody remember? If I add my 9 over, because I set it equal to 0, I get x squared equals 9. How do I finish solving that at this point? You take the square root, and when you introduce a square root, it becomes positive or negative 3. Plus or minus 3.
So we could have gotten x equals negative 2 equals negative 3
No. The other way you could have done it is factored this into x minus 3, x plus 3. So your answers are negative 2, and then positive 3, and negative 3.
Yeah, that's what I meant to say.
Okay. So for this one, like I was talking up above, our largest exponent here was a 3, and how many answers did we get? 3. Got negative 2, positive 3, and negative 3. We got 3 answers there. So your exponent tells you how many answers you should have. All right, example number 6. Again, 4 terms there, so I'm going to do factor by grouping. Group my first 2, group my last 2. What's our GCF for the first 2? X squared. And then I have x minus 1. What's our GCF for the last 2? 3. And then we have x minus 1. So I'm going to make this bigger to try to move it up for the people in the back. So our binomial GCF is x minus 1. And then inside the other parentheses are x squared plus 3. So when we set these equal to 0, I get x equals 1 is one of my answers. For the other one, I would subtract my 3 over. So I have x squared equals a negative 3. And then what do we do? Take the square root. This is going back to what you guys don't like. So we have plus or minus. A negative under the radical turns into what? I radical 3. So then our 3 answers are positive 1, positive I radical 3, and negative I radical 3. That's why we have the i's. Now we can answer every single quadratic question that we possibly have. So how many roots do you get in the last 2 problems? We got 3 roots because our exponent was a 3. That was our highest exponent there. So if we take a look at our next 2 problems, how many answers should we get for these ones? 4. Our largest exponent is a 4, so we should be getting 4 answers. We have factored ones like number 18 before. Instead of having x and x, what do we start with? X squared and x squared. Our sign should be different. One's a negative, one's a positive. So what multiplies to give us 8? 4 and 2. Which one should be my negative? The 4. I'm going to put the 2 there. So for my first one, I add my 4 over, so I get x squared equals 4. Take my square root, what do I get? X equals plus or minus 2. So there's 2 of my answers, positive 2 and negative 2. On the other side, I subtract my 2 over, so I get x squared equals negative 2. Take the square root. We get x equals plus or minus I radical 2. You always got to take that I out if it's there. So there's our other 2 answers. Positive I radical 2, negative I radical 2. All right, then for number 20, what do we have to do first? Subtract our 13x squared, add our 36. So now it's equal to a 0. We're in our standard form. We can go ahead and solve it. Again, we're going to factor this one like we did our last one. This time our signs will be the same. They're both going to be a minus. So we just have to think what multiplies for 36. Adds to give us 13 would be 9 and 4. So first one, I add my 9 over, so I get x squared equals 9. Take the square root of it, and we get x equals what? Plus or minus 3. So there's 2 of our 4 answers. Other side, I add my 4 over, take the square root, and what's our other 2 answers? Plus or minus 2. So if you were to graph these ones, they cross through the x-axis. Well, this first one crosses twice because you got 2 imaginaries, and then the other one would cross through it 4 different times. So number 25, Max tries to solve the following equation as follows. But I'm telling you, he made a mistake. We got to find where his mistake was. So I'm going to give you a second. Let's have you look through, see if you can figure out where his mistake was. The mistake that he made is this negative sign should have been distributed to both things in that parenthesis. So this really should have been a plus 3 as opposed to a minus 3. So then this step here, he should have had x plus 3 and then 3x plus 5 equals a 0. So what should our answers actually be? One of them should be negative 3. What should the other answer be? Negative 5/3. All right, next one on here, solve by extracting the roots. We kind of already been doing that a little bit. That's when you take the square root of both sides, you get the plus or minus thing. These ones are kind of like in the middle of completing the square. That's what they were doing for this. We're in the completing the square steps, kind of in the middle of it. What some people have done is they sit here and they try to take their x plus 2 squared and they write it out, multiply everything, combine your like terms, and then factor. That just takes a lot longer than it really needs to. So for here, we would start by adding your 16 over. So we get x plus 2 squared equals a 16. Then take the square root of both sides. So we would get x plus 2 equals plus or minus 4 because your radical cancels out the squared that was there. Then subtract your 2. So we would have negative 2 plus or minus 4. And then we just have to simplify because we can't leave it like that. So what is negative 2 plus 4? 2. And then negative 2 minus 4? Negative 6. So there's our 2 answers. So as I said, that just goes a lot faster than multiplying everything out. So let's try it in our next example there. Yes. So for this one, you want to add your 6 over first. And then we have to divide by 2 because you want to get what's squared, the x minus 1, by itself first. Kind of like your radicals and your absolute value equations. You want to get those by themselves first. So once you have your x minus 1 squared by itself, take the square root of both sides. 3 stays underneath the square root sign because it's not rational, it's irrational, so we leave it as radical 3. So then our last step would be to add the 1 over. And this time, yes, you have to write that 1 there, 1 plus or minus radical 3. It's not a coefficient. It's a standalone number, so it has to be there. So we have 1 plus radical 3 and then 1 minus radical 3. Now, your last part here, this is on the back. For some reason, it was on my front on this side here for me. But it's the same exact problem. So this is just the example of our other method that we're going to go through today for solving quadratics, completing the square we're going to do next class. That's using your quadratic formula. Now, if you remember, your quadratic formula is on your reference sheet for your regions, but you still need to know how to use it. I like to make a little list first of what my A, my B, and my C are because I feel like it makes it a little easier when you go to plug it into your quadratic formula. You won't lose points for not making that little list. As I said, it's just something to try to make it a little easier. So remembering, A is in front of your x squared term, so our A here is a 2. B is in front of your x term, so our B is a 4. And then C is the standalone number. We call it your constant, which is why it's C. So that one is a 1. Keep in mind, if a term is not there, let's say I had 3x squared plus 4 equals 0. For this example, A would be 3. What would be my B value? 0. There is no x. That means there is no B. B is a 0. So then my C for that one would be a 4. So if that term is missing altogether, that means that value is a 0. So let's go ahead and plug into our formula. You don't have to keep writing the formula every single time, but when you're working on your homework, I recommend at least writing it once up on the top of your paper so you can always look back at it. So we start with negative B, so that just means change the sign value of our B. My B is a positive, so I'm going to make it a negative 4. Plus or minus. Everything under the radical, when you plug in a value, I always strongly recommend that you put it in parentheses. Reason being, especially for this B term, if you have a negative number and you're squaring it and you don't remember your parentheses, 99% of the time you always get it wrong. So please, please, please use your parentheses when you're plugging all that in. So what do we get underneath our radical there? Our 4 squared minus 4 times 2 times 1. 8. Yes. So then the other thing that they don't always tell you is when you're doing these, 99% of the time they want it in simplest radical form, which is why we keep practicing those simplifying our radicals. So how do we simplify a radical 8? What's our perfect square that goes into an 8? 4 and 2. So that becomes a 2 radical 2. I always do that off on the side, or if you can simplify an 8 in your head, go ahead and do that. So I get negative 4 plus or minus 2 radical 2 all over 4. Again, I'm going to make this bigger so people can see it. not quite. Last step, you always got to check these three numbers that are not in the radical. Can I reduce those? Yes. What can I divide them all by? 2. So negative 4 divided by 2 gives me negative 2. Plus or minus 2 divided by 2 gives me a 1. So 1 radical 2. And then 4 divided by 2 gives me a 2. That's my final answer there. Did I have to put the 1 in front of my radical 2? No? Am I wrong for putting it there?